Hello everybody, we are going to be discussing chapter 2.4 in your book, Addition of System of Coplanar Forces. What we're going to be doing today is looking at rectangular components. So when a force is resolved into two components along its x and y axis, kind of a review of what we've done so far. We can represent now x and y components in Cartesian unit vectors I and j. These are called unit vectors, um, dimensionless, magnitude of 1, and used to show direction. So what I mean by that is if I have my x and y, I could say, given a vector, we'll call this vector f, we could say that this here is my force in the y. And we could say that this here is my force in the x. We could also say that now this direction is my j, and this direction is denoted by my I, or we call it I hat. So what we can come in and say that my force then is equal to the force of the x in the I direction plus my force in the y in my j direction. So this gives you your magnitude, and then this gives you your direction. And the same thing with your y. This gives you the magnitude, and this gives you your direction. So really all we're stating here now is that x will be denoted as the I direction and your y is your j. Once we get into three-dimensional, we will be adding our z, which would be a k hat. That's a k hat. So I think the best thing to do is to kind of look at an example. So let's go ahead and do that. So I've got an example here, and I've got three vectors now. I've got 30 Newton vector force, a 15 Newton force, and a 45 Newton force, all given direction from the x-axis. Now, just to note something, this is going to be 30 degrees here. So this angle is all the way to the x-axis. So this is your x, and this is your y. And how we're going to do this one is we're going to use it solving using vector notation. Alright, so let's get started. So this is my given. My find is to compute the resultant force on my approach. So I'm going to use the Cartesian vector notation to do this. Okay, so let's go ahead and do our solution. So let's first go ahead and note a couple of things. I'm going to call this force 1. I'm going to call my 15 Newton force 2 and my 40 Newton force 3. So force 1, we could say is, now it's going in a negative x direction, so we can say negative 30 n times the cosine of 10 degrees, and this is in my x direction, or using the notation of I, plus 30 newtons, because notice that this would be going in a positive direction, going up, times the sine of 10 degrees, and that's my j hat. And remember, just a little bit ago we said that the force, if we So force 1 would equal the force of the x and the I plus the force and the y in the j. So that's what we got here. Throwing these into my calculator, I came up with negative 29.5 I plus 5.21 j. And these are all in newtons. Please don't forget units. Units are so important. Force 2 then. If you would, you should pause the video, write it out, and then come back to the video to see if you have it correct. So force 2 then, again my x is going negative, so it's going that way. If you note that it is going that, whoops, it's going that way. So force 2 is going to be negative 15 newtons times cosine of 60, again my I, plus 15 newtons times the sine of 60, and that's in my j. Again, throwing these into my calculator, I came up with negative 7.5 I plus 12.99 j, all in newtons. Force 3. So I've got force 3 here. I've got 45 newtons. My x and my y are both going to be positive. So if I'm doing my x first, I've got cosine of 30. That's I plus 45 newtons sine of 30, and that's going to be j. My results were 38.9 I hat plus 22.5 j hat, all in newtons. Now I could do summing my forces in the x direction. So if I sum my forces in the x direction, that means I'm going to add all of my x's. So I've got this one, my force 2x, and my force 3x. So I've got negative 29.5 newtons minus 7.5 newtons plus a 38.9 newtons. Now I don't include the I because I'm saying I'm summing my forces in the x. So computing those, I got 1.93 newtons. I could do the same thing in my y. So I'm summing my forces in the y. I'm going to get 5.21 plus 12.99 plus 22.5. So plus 5.21 newtons. Again, I don't use the j because I'm summing my forces in the y. Plus 12.99 newtons plus 22.5 newtons. And I compute that was 40.7 newtons. So now I've got to find my magnitude. I'm going to scroll down just a little bit. I've got to find my magnitude, or the resultant force. So if we graphed my 2 here, my x direction I'm going 1.93, so I'm only going just a little bit right here, right? And then I'm going up 40.7, so I'd be like way up here. So this here then would be my force resultant. So this then would be 1.93, and my y distance, 1.93, and that would be 40.7. So just to draw it over here, this is way off scale, but this would be 40.97, and this would be 1.9, and those are both newtons. So Easy enough, we can use our Pythagorean theorem to find our resultant force. So my force resultant, or my magnitude, is going to be 1.93 squared plus 40.7 squared, and then we take the square root of that. And I came up with 40.7 newtons. And since this is so small, when you round all that out, in a lot of the quizzes I asked to the whole number, so that would be 41 newtons. And easy enough, we can solve for theta. Theta then is tangent theta is equal to the opposite over the adjacent, or 40.97 divided by 1.9. So theta is going to equal arc tangent. I'm sorry. That's right. Tangent is opposite over adjacent. Yeah. So then we can say that this would be 40.97 by 1.9. So if I plug that into my calculator, I got 40.97, divide that by 1.9, and I do the arc tangent, and I get 87.3. So that's this angle right here would be 80.73, and that would be positive from the positive x-axis, since we're going in that direction. If you wanted to compute, erase that. If I wanted to compute it from the y, this angle here, I could just reverse these, because then I could be doing my opposite would be here and my adjacent would be here, and then I would come up with 2.71 degrees. But that would be counterclockwise from the positive y-axis. So the reason that we're using Cartesian notation is, especially when we get into 3D and a lot of vectors, it will really help organize our work. So if you have any questions on this, I am going to upload another example problem here in a few. If you have any questions, please let me know. Thank you.